This is Answer Factory, and today we're talking about computer programming. We're talking about what is a load balancer. Okay, let's go into it. A load balancer is a device or software that distributes network or application traffic across a number of servers. This distribution ensures that no single server becomes overwhelmed by requests, which can improve the responsiveness and availability of applications or websites. How does a load balancer work? Number one, it distributes requests. When a user tries to access a website or a program, the request goes through the load balancer, which then decides which server to send the request to based on certain criteria, such as which server has the lightest load or which has the quickest response time. A lot of the time, it just sends it to a random one. It just does round robining. Okay, two, health checks. Okay, load balancers are continually checking the health of the servers to ensure that they are able to handle the request. So if a server is not responding, the load balancer stops sending traffic to it until it's back online. How do you do a health check? Well, it's usually as simple as the server that is taking the request is just going to have a little API endpoint called health, and the load balancer is going to continually call that health endpoint. And if that health endpoint doesn't return a 200, it's going to say, oh, this server's down. Simple as that. Types of load balancing. Okay, there's several types of load balancing, including round robin, where it just goes server by server. So if there's 5 servers that are being balanced, it just goes 1, 2, 3, 4, 5, and then the next request is 1, 2, 3, 4, 5. Okay, that's round robining. Least connections, which is just having a list of how many connections does each of these servers have and then sending it to the lightest load one. And then there's the IP-based load balancing, which is very useful, which is where it'll basically hash your IP and then it'll have an automatic server that you always send to based on your IP. So that way, someone with the same IP will continually get sent to the same server. Now, that's not really a good idea because we don't want our code to assume that all requests are coming to the exact same server. That's kind of an anti-pattern. So it's not really a good idea to do that IP hash load balancing. The best, in my opinion, is just round robining. It basically, statistically, gets the job done. Okay? And that's the thing. These things work on high scale. So what you really care about is just, does it get the job done? Okay, let's talk about some examples of real load balancers. Okay, there's physical load balancers. Okay, these are physical devices like the F5 big IP, which is used in enterprise environments, and it physically routes requests. Okay, then there's software load balancers. These are applications that perform load balancing. So for instance, you'll have an NGINX server that is configured to sit in front of all the other servers, and it'll actually route requests to your different web servers. Okay, so most people have an NGINX or an Apache server or something like that acting as their load balancer. Okay, then there's the cloud-based load balancers, and these are basically software load balancers, but they're in the cloud. So for instance, AWS has elastic load balancing, Google has their own load balancing solution, so you don't have to go build your own load balancer and deploy your own NGINX anymore. You just say, hey, I have this container and I want it load balanced. Google, go ahead and load balance my servers. And so these days, it's generally just something you specify. Hey, I want these to be, I want my server to be load balanced, and it'll do it. It'll do it by itself. So how do load balancers enhance performance and reliability? Okay, this is why load balancers exist, is for performance and reliability. So number one, for scalability. So with a load balancer, a system can scale up and down on demand. That's the holy grail. As we get more clients, we can add more servers. And the load balancer is the single point where it'll just continually send to more and more servers no matter how many people we have coming to use our service. And you can also do auto scaling, which just basically says we're going to automatically add servers as the usage goes up. right? So load balancer is a core part of an auto scaling solution. 2, redundancy. By distributing traffic across multiple servers, load balancers ensure that if one server fails, the traffic can automatically be rerouted to another server without any downtime for the user. That's super important because servers fail all the time. So if you only have one web server and it goes down, you're screwed. Your website's down. But if you have 5, then one of them goes down, your load balancer just sends everyone to the other 4. Super important. This also is how databases scale, by the way. Same idea. Okay, then there's efficiency. Load balancers optimize the utilization of server resources, which ensures no single server is overwhelmed while the others sit idle, right? So a load balancer is kind of in charge of making sure that all the requests don't go to just one server. It's very good for overall efficiency. So load balancers are like the traffic cops of the internet, okay? They ensure data flows smoothly and efficiently to the destination without overwhelming any single server. By intelligently distributing requests, load balancers enhance the performance, reliability, and scalability of web applications, making them absolutely indispensable parts of any application infrastructure. All right, well, that's it. That's everything you need to know about load balancers. Hopefully you don't have to implement one yourself. If you do, you should go try NGINX. Go try setting up an NGINX with a couple servers behind it. And that'll get you started, kind of figure out how this whole thing works. Yeah, this is everything you need to know about load balancers for web developers. If you like this, just send me a like or a subscribe, and I'm happy to do more. Ask me any questions you have, because this is the Answer Factory, and I'm on a quest to answer every single question on the entire internet. So, yeah, let's do this. Okay, have fun. Talk later. Bye now.